Greetings everybody, myself Palkumar Pat. Welcome to LeetCode problem solving series. Today we are going to solve 3 questions at once. Yes, because we are going to solve all the power of questions like power of 2, power of 3 and power of 4. All 3 questions in this single video only. So obviously because all of them contains a similar approach, we just need to change the numbers from 2 to 3 and 3 to 4. So we'll start by understanding our problems and then move to directly the solution, the approach to solve it. Okay, because it is much simpler, all of 3. So let's just start by understanding what our problem is trying to say. So we will first take power of 2, okay, and after solving it completely, then we will move to the power of 3 and 4. Okay, so for reference, we are going to take power of 2 in our main consideration. Okay, so let's just understand. Now we are given a simple single integer as an input, and we just need to check. Our task is simple, that we need to check if our given integer is a power of 2 or not. Okay, like let's say we have 16, so we know that 16 is the power 2. How? Because 2 to the power 4 is 16. But let's say 15 is not a power of 2 because there is no power of which 2 when power to that number it never gives 15. So 15 is not a power of 2, and so we will return false. Okay, this way our function is boolean, as you can see, because we need to check and we need to return true or false based on the given input integer. Okay, this is our simple task. Now let's move to the solution, the straightforward idea to solve this problem. Okay, now see, what I am thinking is many of you would have just figured out that the number that you are given, okay, if it is modulo 2 equal to 0, okay, now there can be other numbers too, but if modulo 2 equal to 0 and we continuously divide it by 2 again and again repeatedly, and at the end if we have 1 like at some point after dividing continuously, if we have 1 at some point, we know that yes, it is the power of 2. Why? Let me give an example. See, if we take this test case, we have n equal to 16. Now let's think in mind by continuously dividing 16 by 2. So 16 by 2 8, 8 by 2 4, 4 by 2 2, and 2 by 2 equal to 1. Now as I mentioned, we know that at some point after continuously division we are getting 1. Now we know that yes, if it's 1, that yes, it is a power of 2. But let's say we take, now many of you would just say that there are other integers too which are not power of 2, but their division by 2 is perfectly done. So let's take another example. See, let's say we take a 6. Okay, 6 by 2 is equal to 3. It is divisible by 2. But if we do 6 by 2 3, now 3 by 2 it can't give 1. Okay, why? Because let's say 3 by 2, so it will give 1.5. It's not perfect 1. So we know that yes, it's not perfect 1. So we will return false. Okay, simple. Like that way we can take other integers too. If we pass them through that part, that check that if it continuously divided by 2, if it gives 1 at the end as a perfect whole integer, then yes, it is true. Otherwise we'll return false. Okay, so let's just move for that. Okay, now then to again mentioning, for this continuous division we are going to use while loop, obviously, because we don't have fixed number of iterations, so 4 can't be used. Okay, so we are going to use while loop, and inside while loop, as I mentioned, our check will be that if the number modulo 2 equal to 0, then and then only divide it continuously, otherwise simply return false. Okay, in the 6 test case, many of you would be saying that for C++, 1.5 is considered as 1, so it will pass. But no, because we are checking modulo 2 equal to 0, 3 modulo 2 is not equal to 0, so division will never be done and it will completely return false at n equal to 3 only. Okay, that way we can pass that type of test cases too. Okay, so please stay and just check the code. Okay, now let's move for coding the part. Okay, coding the approach. As I mentioned, also let me mention another thing, that in test cases we can have negative integers too. Okay, it's mentioned in the constraint that n, our input integer, can be negative 2, minus 2 to the power of 1. So you know that any negative integer can't be a power of 2 or power of any number. So for that, for dealing with them, we are just going to use a simple if at the start of the code only, that if n is less than or equal to 0, simply return false at the start point itself of the code. Okay, and if it's not, as I mentioned, we are going to use while loop, and inside the while loop, as I mentioned again, that n modulo 2, if it's equal to 0, then and then only process it, like divide it. And as I mentioned, the process is simple. We will be dividing it continuously. After completion of this loop, okay, now let me give let me dry run a test case. Okay, let's take 16. So 16 modulo 2 is equal to 0. Yes, so 16 by 2, 8. Similarly, 8 modulo 2 equal to 0, so 4. 4 modulo 2 equal to 0, so 4 divided by 2, 8, 2. And again, 2 modulo 2 equal to 0. So 2 divide by 2 equal to 1. Now at this point, 1 modulo 2 is not equal to 0, it's equal to 1. So our while loop will break, and as I mentioned, we will simply check that if n is equal to 1, return true. Otherwise, here simply return false. Done. This way, the odd test cases like 3 and 5 and 15, all of them will never be modulo 2 equal to 0. So they will directly return false. Okay, and test cases like 6 at some point after division, 6 by first time, because 6 modulo 2 equal to 0, so 6 by 2 equal to 3, but 3 modulo 2 not equal to 0, so it will check like while will break and n equal to 1, no, because n is equal to 3, so it will return false. Okay, that way all the type of test cases can be covered for this code. Okay, so this was a complete code. Let's just check for the cases. If it works for that. Okay, yeah. Let's just submit. Okay, so it can be 100 only. You can check by running it yourself. Because of my some network error, it's causing this. Okay, no. So this was a complete approach for power of 2. Okay, let's just move for power of 3 and 4. Okay, as I mentioned earlier, the solving for power of 3 and 4 are similar. Like we just need to copy this code and we just need to use directly inside 3 and 4 also. Okay, let's just load this. We just need to here and we just need change 2, 3. Okay, and our other parts of the code will be similar and exact same. Okay, let's check. Okay, I hope I don't need to explain this again, because you know that instead of division and modulo checking by 2, we just need to check it by 3. That if let's say 27 modulo 3 is equal to 0. So again, after continuous division, at the end, at some point, n will be equal to 1. Okay, this is similar for 5, 6 and all other numbers, like all k. Let's say it k. So for all keys, it will be similar. This simple code, but 3 replaced with k. So similarly, as I mentioned, let's just submit power of 4 also. So now let's just go for power of 4 also. So yeah, as I mentioned, we will just paste it here and replace it with 4. Okay, division by 4 and modulo by 4. Okay, yes, it works. Okay, I also have another, yeah, it works properly. Another approach for modulo by 2. We can use, see, as you can see, just now it was giving less time and it's showing now 100%. So it is because of all of the questions are solved till now. Okay, now as I mentioned, I also have another shorter approach, like more optimized for solving this problem. Okay, let me show you why. Here you can see we have a follow-up, like could you solve it without loops and recursion? So yes, we can solve power of 2 without loops. How? Let me mention you. Okay, see, let's say we take an example of 8. Okay, because 8 is a power of 2, so it should return true. Now instead of doing loops again and again, what we can do is that we know that a number can be like represented in the form of its binary part. Okay, so as you can see, let's say we have 8 as our test case, so 8 can be represented as 1000. Why? Because 0, like not 0 but 1, 2, 4 and 8. So 1, 2 and 4 will be 0 and 8 will be 1. So we can represent 8 as 1000 in the form of binary part. And what if we take 7? Like after subtracting 1 from 8, we have 7. So when we try to represent 7 in the form of binary, it will show 0, 1, 1. Okay, this is a simple thing. It can be applied to any number. Like if we take 16, so 16 will also take us show us 10,000 as a binary part, and 15 will show us 0 and 4 times 1. So this is a trick. Like if we apply AND operator between 8 and 7, it will give us 0. Okay, so now we have a trick that if our current number, if it will be a power of 0, then when we apply AND operator between that number, our current input number, and that number minus 1. Okay, if we apply AND operator between both of them numbers, it will give us 0. So we just need to check that if our current n, okay, our current n AND operator n minus 1, if that is equal to 0, then just return true, otherwise return false. Okay, this way we can solve this problem without loops. Okay, also we just need to add the if condition for negative, like dealing with the negative integers. Okay, so here it will be the same if that we used in the earlier approaches. Okay, so I think this can, because this is a trick to solve this without loops and recursions. Okay, let's just run for the main test cases. So yeah, it works. Let's just submit this code. Okay, now as we can solve without using loops. So yeah, it gives 100% now. So this is the most optimized form, the latest and most optimized way to solve power of 2. Okay, you can apply this to power of 3 and 4 too, but for them you need to give extra checks for greater test cases. Okay, so I'm not demonstrating it here. So this way we can solve all of these 3 problems. Okay, so this was the solution for solving this problem. If you like the way I mentioned and approach the questions, you can like the video. If you have any feedback, positive or negative, you can apply them in the comments below. I will check that and answer you also. And if you want to check other questions like this, I have made a LeetCode problem solving series playlist from where you can check them. I'm also going to add more questions. So for staying along, subscribe to the channel. And also, if you want to connect with me personally, you can use my social connections link present in the description of the video. Thank you for staying till the end. Thank you very much.